Hello, good evening, everyone. So let us check these physics objective questions. The first question is the force between the molecules of a liquid in contact with that of a solid is, we have adhesive, cohesive, magnetic, repulsive. Now you remember that adhesive forces are the attractive forces between molecules of different substances. You agree with me that liquid and solid are not the same, when we consider them as different kinds of matter. So when we have a force between molecules of different types of matter, then we have adhesive forces. Okay, so these forces are the ones that cause the liquid to stick or adhere to the surface of the solid. However, the cohesive forces are the forces of attraction between like molecules, that is, similar molecules, like liquid to liquid, solid to solid, that is that. Now, the second question is a reservoir is filled with a liquid of density 2000 kilogram per meter cube. They ask us to calculate the depth at which the pressure in the liquid will equal to 9,100 Newton per meter square, and they have given us gravity, to be 10 meter per second square. So how do we solve this? We start by using the formula. The formula we are going to use is P equals PGH. Okay, we want to look for the pressure exerted by a liquid column. Okay, so they have given us the density, and they have given us the depth at which the liquid. Okay, they ask us to calculate the depth at which the pressure in the liquid will equal to what they have given to us. So the P is the pressure, which is 9,100 Newton per meter square. Then we have the small p, which is the density of the liquid, which is 2,000 kilogram per meter cube. Then we have G. G is the acceleration due to gravity, and H is the depth. Okay, so since we are looking for H, so we have to rearrange the formula. Okay, so that would be H equals P over small pg. Okay, then that will be 9,100, which is the pressure, divided by the small p, which is 2,000, multiplied by 10, which is gravity. So if you divide that, definitely the depth that we are looking for, which is H, will be 0.455. So the correct option will be B. Then the number 3 question is a solid weight 45 Newton and 15 Newton respectively in air and water. Determine the relative density of this solid. Another name we can call the relative density is specific gravity. Okay, so the relative density of the solid has been given. Okay, and the relative density will be the weight in air over loss of weight in water. Okay, the weight in air over loss of weight in water. Now, if you can remember, they tell us that a solid weight 45 Newton and 15 Newton respectively in air and water. So respectively there means 45 Newton will go to air and 15 Newton will go to water. Do you understand that? That's the meaning of respectively. 45 Newton for air, 15 Newton for water. meaning that we have our weight in air already, and our weight in air is 45 Newton, while the weight in water is 15 Newton. So how do we calculate loss of weight in water? It means we are going to subtract solid weight, in water from that of air. So that is why we are having 45 Newton minus 15 Newton, which is 30 Newton. So the relative density will now be weight in air, which is 45 Newton, divided by the loss of weight in water, which is 30 Newton. So we are going to be getting 1.5. That is option C. Okay. The reason you have this is to be able to, I try as much as possible to provide these solutions for you so that you can take your notes while listening to the video. Then they say one common characteristics of solids, liquids, and gases is that, okay, when we talk about solids, liquids, and gases, what is one thing that is common to the three of them? And the correct option there is that their molecules are always in motion. Okay, all of them, they don't have a fixed volume. Okay, if we use the ice cube for instance, if the liquid becomes an ice cube, you will discover that the volume will not be fixed. Okay, the volume will not be fixed. Then they don't have the same size. It's not possible. Their molecule they have the same size. No. Then all the three have same intermolecular forces. Not at all. The intermolecular forces are not even in gases. Okay, if you remember the principle of ideal gas, the law of ideal gas. Okay, so now they now say that one common characteristics to all of them is that their molecules are always in motion, meaning that they are constantly in motion. Though nature and extent of the motion may differ, they may not be the same. For instance, in solid, the molecules can vibrate around a fixed position. Let's give example of that. If you put your phone, for instance, on a table, there could be some sort of vibration, and you can see that the solid is moving, but it is at a fixed position. Okay, in liquids, they can move freely, the molecules can move freely, but they will still be close together. Okay, it's just like you are pouring water. The water can move freely, but they are still close together. However, the molecules, in gases, they are rapid and they move far apart. Okay, so the correct option is that their molecules are always in motion. Then the next question is, a boy travels 8 kilometers eastward. I want you to look at, you still remember the equator that they taught you in school, the cardinal point. From your north, to the east, to the west, then to the south. So they are telling us here that the boy travels 8 kilometers eastward to a point B. Okay, eastward to a point B. So the boy has to move, eastward to a point B and northward to point C. Okay, that is the diagram there. 8 kilometers to the east, then 6 kilometers to the north. So they asked us to determine the difference between the magnitude of displacement of the boy and distance traveled by him. So let's first calculate the distance. The distance, would be 8 kilometers plus 6 kilometers, then definitely that will be 14 kilometers. Now, how do we calculate the magnitude of displacement? The magnitude of displacement is easy. We are going to be using the Pythagoras theorem. Okay, now you can see that what we are looking for there is the hypotenuse. the opposite is 6 kilometer, the adjacent is 8 kilometer. So that will be hypotenuse squared will equal opposite squared, plus adjacent squared. And that will be 8 squared plus 6 squared. That will give us 100, and that is 10 kilometer. Now, what is the question? They ask us to look for the difference between the magnitude of the placement of the boy and the distance traveled by him. So that will be 14 minus 10 kilometer, and that will give us 4 kilometer. So that will be option B. Now to question 6. They say that the magnitude of the force required to make an object of mass m move with speed v in a circular of radius r is given by the expression. Okay, let me repeat that. The magnitude of the force required to make an object of mass m move with speed v in a circular of radius r is given by the expression that. Okay, you remember, centripetal force. Okay, the magnitude of the force that is required to make an object move in a circular path is actually the centripetal force, and the formula for centripetal force is mv squared over r. Mv squared over r. Okay, please don't let us forget that. Mv squared over r. So that will be mass multiplied by the v is squared, which is the speed is squared. Then we are going to have it over the radius. Now on to the next one. They say a man was moving around a circular path continuously for 4 minutes. Okay, the man was moving around a circular path continuously for 4 minutes and covered the following distances in the time stated. Okay, distance in meters: 200, 400, 600, 300. Then the time in minutes is 1, 2, 3, 4. So 200 meter, in 1 minute, 400 in 2 minutes, 600 in 3 minutes. Then, another 300 in 4 minutes. Okay, and also which of the following statements is correct about the motion of the man? Now, the interesting thing is the speed was changing constantly. Okay, the speed was changing constantly. When we talk about this kind of question, we need to consider the total speed covered in each minute. We need to see if they are the same or they are different. You will discover that the man traveled moved around 200 meter in 1 minute, 400 meter in 2 minutes, etc. So this indicates that the speed was not uniform. The speed was not uniform. Since speed is the distance traveled per unit time, then the changing distances imply a varying speed. Okay, now the next one, they say a car takes off from rest and covers a distance of 80 meters on a straight road in 10 seconds. A car takes off from rest. From rest means the initial velocity is 0 meter per second, and they say that it covers a distance of 80 meters on a straight road in 10 seconds. Calculate the magnitude of its acceleration. Okay, so here we can be using the equation of motion. If you still remember, that is s equals ut plus half at squared. Okay, now you have your displacement, which is 80 meter. Then you have your u, which is 0 meter since it is from rest. Then you have your t, which is 10 seconds, and then you are a is our acceleration. So if we are going to put that, since we are looking for a, so if you are going to put that, substitute the values. So s will be 80. Okay, then our u is 0 multiplied by 10, which is time. That will still be 0 plus half. What is then we have a that we are looking for, and our t, which is time, will be 10 squared, which is 100. So 80 equals half a times 100. So that will be 80 equals 50a. So divide both side by 50. So a will be 1.6 meter per second squared. So that will be option B. Then the next question is, an object is released from rest at a height of 25 meter. At a height of 25 meter, they ask us to calculate the time it takes to fall to the ground. Okay, the time. So we can still use equation of motion this time around. We have S equals ut plus half gt squared. Okay, that is our gravity. G is our gravity this time around. Okay, not acceleration anymore. So we have the displacement to be 25 meter. Then we have the initial velocity to be 0 since it is from rest. Then we have the G, then T is the time that we are looking for. So that would be 25 equals 0 plus half times 10 times t squared. So 25 equals 5t squared, and we can divide both sides by 5. Then that will be t squared equals 5. Then the square root of 5 is 2.24 seconds. So fixing that, we go back to our question. The correct option will be 2.24 seconds. I believe you can see that very clearly. Then again, say an object is acted upon by a system of parallel forces causing the object to be in static equilibrium. Which of the following statements is not correct? Okay, when an object is in static equilibrium, the following conditions must be met. You can see it. The resultant of all forces acting on the object must be 0. So meaning option A is correct. It must be 0. Then the algebraic sum of the moment of the forces about any point must still be 0, because we are talking about equilibrium here. Okay, so static equilibrium. Then we have that the sum of the forces in one direction must equal to the sum of forces in the opposite direction. Yes, that is how equilibrium works. Okay, then the incorrect option here is that all the parallel forces must be equal in magnitude and direction. No, they may not be equal in both magnitude and direction. It is not necessary. Okay, in fact, they can only need to balance each other out. Okay, they don't have to be equal. So that will be option C. They don't have to be equal to balance each other out. So that is option C. Then the next one, they give us a diagram. They say an object A is held in equilibrium as dash. So they say we can see T2 15 Newton, then we have T1 8 Newton, and then we have W. So they ask us to determine the magnitude, that is W, of the weight. Okay, and it's so easy. If you look at what we have here, it's like maybe we have our hypotenuse, then we have our adjacent, then something like we are looking for. Okay, so we are looking for our W. So we can still say we have T2 plus T1. Okay, that would be T1 squared plus T2 squared. So that would be 8 squared plus 15 squared, and that would be 64 plus 225 equals to 89. That would be 17 Newton. Square root of 289, 17 Newton. So that is the weight. Okay, then they say a spiral spring of natural length 30 centimeter and force constant 20 Newton per meter is compressed to 20 centimeter. Calculate the energy stored in the spring. We should calculate the energy stored in the spring. Okay, now sorry, permit me to say there's a kind of mix-up when I was arranging this. I meant to solve the problem to question 12 using E equals half kx squared. Okay, Then the K is the 20 Newton per meter that you can see there, which is the force constant. Then X is naturally the compression from the length. So for us to get the compression, we are going to remove 20 centimeter that thing is compressed to from the natural length, which is 30. So we are going to get 10 centimeter, and to convert it to the acceptable unit, which is meter, and that will be 0.1. So we can say E now will equal half multiplied by 20 multiplied by 0.1 squared, because that is our X. And if you do that, you are going to be getting 0.1 joule. Okay, that is option A. Please make sure you write the equations, and at the same time you try to solve along. Okay, thank you. Then the next question, which is question 13, it says, which of the following statements correctly defines quantitatively the work done by a force? Okay, the product of the force and the distance moved dash. Okay, so we have options like parallel to the line of action. Because of our time, that's the correct option. What we are trying to say here is that we want to define work done by a force. Okay, so it means that the product of the force and the distance, they moved parallel to the line of action of the force from a reference point. So you discover that mathematically what we are saying is that work will equal force multiplied by distance multiplied by cos theta. Okay, and theta will be the angle between the force and the direction of motion. Okay, so it means that the product of force and distance will move parallel to the line of action of the force from a reference point. Now, so that is option A. Then we say a load of mass 120 kg is raised vertically through a height of 2 meters in 30 seconds by a machine whose efficiency is 100%. Calculate the power generated by the machine. Okay, now to calculate the power generated by the machine, we are going, you want to calculate power, you are saying work done over time. Okay, so, and work is mgh. Okay, so definitely the work will be 120 multiplied by gravity, which is 10, then multiplied by the height, which is 2. So we are getting 2,400 joules. And the power now will now be work done divided by time. So that will be 2,400 divided by 30, and that will be 80 watt. Okay, 80 watt. That is 80 watts, option B. Then a block and tackle system has 6 pulleys. If the efficiency of the machine is 60%, determine its mechanical advantages. MA is velocity ratio multiplied by efficiency. So now if you look at velocity ratio, the velocity ratio is 6. Okay, velocity ratio for a system with 6 pulleys is 6. Then the efficiency is 60%, which is the same thing as 0.6. 60 divided by 100. So that will be 6 multiplied by 0.6, and that will be 3.6. So that is option C. 3.6, option C. I hope you were able to get one or two things. Please make sure you go through the questions again. These are 15 questions in physics. Make sure you take your notes. Okay, it is very important. You can pause the video, and if you have any question, you can drop it on the group. Then I will try as much as possible to address it. So this is another method we will still be using to learn. Okay, so thank you.